Uh, Okay, maybe from now onwards, it's about fourth semester. Okay, so I'm taking that is 403. Okay, in that heterocyclic chemistry I'm taking now. Okay, so what I will do, I will yes, yes.
But can you wait for 5 more minutes, sir? People are still logging in.
Okay, no problem. You just talk to Naganishita. What happens? She is not joined now.
Sir, still 5 to 6 members are not logged in, sir.
Okay, okay. Maybe I will wait a few more minutes.
ಅದು ಅಣ್ಣಂದೇ.
Okay. So, okay, then now, so I'm taking paper 403. So under that, I'm starting heterocyclic chemistry. So in this heterocyclic chemistry, we are going to discuss about 3-membered rings, 4-membered rings, 6-membered rings, and higher ones. Okay. So I will start directly the syllabus only, because I don't want to explain about what uh, and all you are going to, the remaining syllabus and all those things you can find in your syllabus copy, more particularly in the BC unit. Otherwise, I can also give you the syllabus copy. It is available in the BCU portal. So I'm directly going to the paper, more particularly 403. Under that one unit I'm starting, that's name is heterocyclic chemistry. So in this, so I will start with the 3-membered ring. So 3-membered ring. So you can found here. Maybe what I will do, I will go for a presentation mode. Okay, and I will take a pointer. Okay, so I will go back. Okay, so aziridine. Aziridine means a 3-membered ring. Okay, this is 1, 2, 3. 3-membered ring with nitrogen as the hetero atom. Such compounds are called aziridines. And this will be a substituted aziridine. Of course, this is also a substituted aziridine. Okay. So here, what you can found, a 3-membered ring, okay, with the nitrogen as the heteroatom. Such compounds are said to be aziridines. Okay, so more what you can see. Okay, so what you can see that this is one aziridine. So it's also called as ethylene imine. Okay, this is a substituted aziridine, N-methyl aziridine. And this, what you can say that, you can say that cyclopento aziridine, not this name. So this one you can consider. Then aziridines has often been called azacyclopropane. Azacyclopropane are more commonly derivative of parent alkene, ethylene amine. Okay, so these are the names of aziridine. So with this, I will go to the I will go to next slide. So next slide, we are talking about the physical properties of this 3-membered nitrogen-containing heterocyclic compound. More particularly, it's a cyclic heterocyclic compound, saturated heterocyclic compound. See, when you are comparing with the basicity, so this is one just comparison with the dimethyl amine. So dimethyl amine is more basic compared to the aziridine. So that's because of the strain. I think you know that a 3-membered ring will have a more strain. So more particularly the Bayer strain, angle strain, okay, bond strain, okay, Prolog strain. So these are the strains are present in a 3-membered ring. So because of strain, so this is less basic compared to the dimethylamine. Suppose if there is a question, explain why aziridine is less basic compared to the dimethylamine. So then you can say that in aziridine, it's a ring structure one. It contains strain. So because of that strain, it is less basic. And also you can now explain about the pKa of aziridine is 8. So whereas the pKa of dimethylamine is 11. So that is the reason dimethylamine is more basic compared to the aziridine. So then aziridine ring is a planar. So this one is planar and rigid. The internal bond angles are very close to 60 degree compared to the 113 degree for the chemical properties. So this is here 113 degree. Then one of the most important reactions of small ring compounds is the ring opening reaction. So ring opening means, suppose if aziridine is treated with its halogen acid. So halogen acid may be a HCl, HBr, HI. Okay. So then what will happen? There will be a ring opening. That means no longer the three-membered ring. It will be converted into a open chain compound. So these rings are strained. So since I mentioned that three-membered rings are more strained, so then they tend to come out from the strain. So then what will happen? It will react with the halogen acid and forms a open chain structure. So these rings are strained, and relief of strain makes ring opening more facile. The most readily cleaved bond is CN bond. So that means the bond between carbon and nitrogen. This can be cleaved or this can be cleaved. Okay, just by treating with halogen acid. So with this, I will go to the next slide. So here I'm explaining about the ring opening reaction. So aziridine reacts with HCl. So I am taking HCl to give beta. So beta means this is a functional group. This carbon is alpha. This carbon is beta. So beta chloro ethylamine. So name of this compound, beta chloro ethylamine, hydrochloride. So this HCl is called hydrochloride by CN bond cleavage. So here I'm taking a phenyl, 2-phenyl aziridine. So 2-phenyl aziridine, when it is treated with the hydrochloric acid, what will happen? There will be a ring opening, more particularly cleavage between the carbon and nitrogen, and forming a chlorophenyl. So this one is chloro, this one is phenyl. Chlorophenyl ethylamine. This is 1, 2, ethylamine. So it's a trivial name of this compound. So this is about the reaction. So if you want to look into the mechanism, how this particular reaction happens, then you can look into the mechanism. So mechanism, the lone pair or the bond pair. Lone pair or bond pair present in a aziridine reacts with the proton, giving rise to protonated aziridine. So this protonated aziridine, so you know that this particular bond is cleaves. Why this particular bond is cleaving? Because the formed one, the formed carbocation is the one which is a more stable one, because it's a benzylic cation. This is phenyl, no? That is the reason it's called benzylic cation. Benzylic cations are more stable because they are stabilized by resonance. So once the cation is formed, then a nucleophile. Here the in HCl, H is proton, Cl is nucleophile. Means Cl minus can attack this carbocation, forming a compound like this. Later on, one more molecule of HCl forms a salt. So this is how the ring opening reactions occurs. So what will happen here? A aziridine undergo protonation. The protonated one is undergoes cleavage, forming a more stable carbocation, and then a nucleophile is attacks the carbocation, forming a product. So this is about the ring opening reactions of aziridine. So then what I will do, I will take an example. So here I am taking aziridine itself. So when aziridine is treated with HCl, we are getting beta chloroethylamine. How you can say that beta? Because this is alpha, this one is beta. So beta chloroethylamine hydrochloride is the product. So with this, I will go to the next slide. So next slide, what we are discussing, we are discussing about the free radical reaction. So free radical reaction, is it free radical? It should be a Friedel-Crafts reaction. Friedel-Crafts alkylation, acylation. So it's a name reaction. So what it means? It means that aziridine can act as an electrophile, isn't it? So that means it is an electrophile and it is used in the Friedel-Crafts reaction. What it means? It means that aziridine reacts with benzene. So this is the benzene in presence of anhydrous aluminum chloride. So to give beta phenyl. So beta, how it is beta? You can observe that this is the functional group. This one is alpha, this one is beta. That means beta phenyl ethyl amine is the product. So how this is the representation of reaction with the mechanism. So this is a aziridine in presence of anhydrous aluminum chloride. So what will happen? So you know that the lone pair present on the nitrogen can react with this aluminum, forms a bond between nitrogen and aluminum. Once there is a bond formation between the nitrogen and aluminum, this bond weaks. Once this bond weaks, then the benzene attacks this carbon and forming a product. So this is about the Friedel-Crafts reaction. So then we can, with this, I can go to the next slide. So that is replacement of hydrogen atom. So what it means, more particularly NH proton. So NH proton is a labile, so that can be replaced with other reagent. And these type of reactions are called N-alkylation or N-acylation. So alkylation means one should treat with alkyl halide or methylating source. So N-acylation means one should treat with the acylating agents. Acylating agent may be a acetyl chloride, acetic anhydride, or anything, or benzoyl chloride, whatever it is. So then what will happen here? The hydrogen and the nitrogen, that means NH proton on aziridine is reactive and can be replaced with appropriate reagent. So here I am taking two examples. So when it is treated with butyl lithium is a base. So what it will do? It only captures this proton going out as a N-butane and N-lithium anion is forming. That anion, what will happen? It will react with the methyl and iodide will go out. So lithium iodide, N-butane is the living group and the product one is, and the obtained product is, if you want to name N-methyl 2-phenyl. So this is 2-phenyl aziridine. So name of this compound. So this is how a replacement of NH proton, okay, with the reagent called it's a base. N-butyl lithium is a base in presence of alkyl halide. Here the alkyl, name of the alkyl halide is methyl iodide. So similarly, here what you can observe, triethylamine is a base and chloroformate. Name of this compound is called chloro. This one is chloro and this one is ethyl. It's only one carbon atom is there, no? That is the reason it's formate. So chloroethyl formate is the electrophile. So what will happen here? This triethylamine, the lone pair or the bond pair can attack electron deficient carbon. Here Cl will go out. Cl and H. HCl is taken by the triethylamine. That means triethylamine is gets converted into quaternary salt, and there will be a bond formation between this nitrogen and then this carbon. So that is the product is obtained. How you can name this product? So this is one carbon, carbon number one means numbering. This is one, this is two. That means 2-phenyl aziridine. So aziridine is a three-membered ring with nitrogen, and ethyl. So ethyl means this one, ethyl carbamate. So name of this compound is 2-phenyl aziridine ethyl carbamate. Okay. So this what and all we discussed up to this. We discussed about the ring opening reaction. We discussed about the Friedel-Crafts reaction. We discussed about the NH proton replacement with the alkylating or acylating reagents. So with this, I will go to the next slide. So next, we are discussing about the one more three-membered heterocyclic compound that is called oxirane. So that means in a three-membered ring, if nitrogen is present, is called aziridine. In a three-membered ring, if oxygen is present, is called oxirane. So this is the substituted aziridine. So more particularly, 2-methyl oxirane is the name of this compound. Then, so we'll go to the saturated heterocyclic. So saturated means there is no double bond, no double bond. That is the reason saturated heterocyclic three-membered ring containing one oxygen atom is known as oxirane ring, has also been designated as epoxide, ethylene epoxide. The next member is propylene epoxide. Okay, so right. So what so this one is propylene oxide. This one is ethylene oxide. So then one more name for oxirane is epoxide. So let's look into the chemical properties. So as in the similar case of aziridine, oxirane similar to aziridine undergo fissile ring opening reaction. So with this, I will go to the next slide. So it's a ring opening reaction. So you know that a three-membered ring is a strained one. So because of that strain, so it will undergo ring opening when it is treated with acid source. Acid source may be a H plus or maybe a, yeah, that is only H plus only. So H plus may be from HCl or maybe from HBr or maybe from HI. So what will happen? There will be a ring opening, and in this case, oxirane. So the products are glycols, the vicinal diols. So vicinal diol means hydroxy groups are attached to the adjacent carbon atom is called vicinal diol. So then what is the? It's also called as glycol. Okay. So because two carbon, this can be obtained from glycolic acid. That is first time the glycol is obtained from the glycolic acid, means oxalic acid. That is the reason it's called glycol. So then 2-methyl oxirane is taken, and it is treated with suppose it is treated with the proton source. The proton source may be a HCl, H2SO4, HBr, HF, HI. Okay, so what will happen? The lone pair present on the oxygen can attack the proton, forming a protonated one. So then afterwards, what will happen? You know that methanol, the lone pair present on the oxygen can attack a what is called less hindered. So this is more hindered. This is less hindered carbon, giving rise to a major product. Of course, it can also attack hindered carbon atom. So uh, then the product obtained one is in less quantity. So that what it means? It means that you can observe that this is a symmetrical epoxide. So in this what means nucleophile can attack either this carbon or that carbon, whereas in the unsymmetrical epoxide, uh, less hindered attack one is the major product, more hindered attack one is the minor product. So that's what you need to remember as far as propene oxide is concerned. So with this, I will go to the next slide. So here I'm explaining about the mechanism. So I'm here I'm taking a unsymmetrical epoxide. So the lone pair present on the oxygen abstract a proton, forming a protonated epoxide. And at this stage, this particular bond breaks, and the lone pair or the bond pair on this oxygen can attack this carbon, forming a major product. It is also possible to attack, suppose if this bond breaks and this lone pair is attacking this carbon, then this will be the product, minor product is obtained. So, and one more thing here, quite interesting thing you need to remember. So that is when we are taking a uh, 2-phenyl epoxide. So 2-phenyl epoxide, it is observed that only one product is formed. So why? Because it's because of the formation of stable carbocation. So what it means? It means that the lone pair present on the oxygen can obstruct this proton. Once there is a protonated epoxide is formed. So at this time, the nucleophile attacks this carbon only, not this carbon. Here you can observe that this is a less hindered carbon, whereas this one is more hindered carbon. So, but what is the observed thing? What is the observed one? Here, why it is attacking only this carbon atom? Because the carbocation formed here is called the benzylic cation, and that benzylic cation is more stable. So that is the reason nucleophile attacks benzylic cation, forming only the major product. So this is about the in the case of phenyl epoxide. So that is the difference you need to remember about the what you call phenyl epoxide and then methyl epoxide. So with this, I will go to the next slide. So here, I'm talking about the reaction with organometallics. So here, the reaction between oxirane. So this epoxide is called oxirane. Okay. So the reaction between oxirane and the Grignard reagent. So Grignard reagent, here I'm taking phenyl magnesium bromide. Okay. So then is extensively employed for the preparation of primary alcohol. Here you can observe that this is a primary alcohol. And higher homologous means carbon-carbon bond can be formed, and the obtained ones are alcohols. So what will happen here? So this will be the here, so that means epoxide. But again, here also one can say that epoxide is acts as a electrophile, and phenyl magnesium is a nucleophile. So there will be a nucleophilic addition. How the phenol here pH means phenol, what you call phenyl group, phenyl, and here the anion. This anion is attacking this carbon, and this bonded pair picks up this MgBr. So that is what the intermediate is obtained. So this intermediate, when it is treated with H plus, means acid, that acid breaks this OMgBr and giving rise to primary alcohol. And then suppose if you are taking this is a symmetrical epoxide, and here unsymmetrical epoxide, because this carbon nature is different. this carbon is more substituted one compared to this one. So in the case of unsymmetrical epoxide, then nucleophile, more particularly uh, methyl lithium. So this can attack less hindered carbon, and also it can also attack more hindered carbon. What it means? It means that it is possible to get two products. Okay, that's what you need to remember. So the CH3 minus cannot, if it is attacking here, then this product is obtained. Okay, CH3 lithium, if it is attacking this carbon, means less hindered carbon, then this product is obtained. CH3 lithium, if it is attacking more hindered carbon atom, then this will be the product. So with this, I will go to the next slide, means continuation. Suppose if you want to prepare regio selectively, that means if it is attacking at only one site, so that means regio selectively the product is formed when we are using dimethyl lithium cuprate. So this is again a alkylating agent. So that means in this CH3 minus means carbanion is the source. That carbanion can attack less hindered carbon, forming only one product. So there is no other product. That is the reason what we can say that regio selectively we are getting only one product. So when we are using dimethyl lithium cuprate as the alkylating or nucleophile. So then let's also discuss one more reaction called reduction. Suppose a epoxide. So epoxide is subjected to reduction. So here I think you are aware about the lithium aluminum hydride. So lithium aluminum hydride is the reagent. It acts as a source of HI, H minus. H minus means hydride. So then what will happen? The hydride can attack less hindered carbon. So not the more hindered carbon. So that is the reason the product obtained one is 1,1-hydroxy, 1-phenyl kethane. Okay. So this is about the reduction. So with this, I will go to the next slide. I will go to the next slide. Right. So next is about the thyrane. So thyrane means, right. What I will do, just I will sum up. So that means up to this, we discussed about a three-membered ring with nitrogen is called aziridine. Three-membered ring with oxygen is called Oxirane. So since these are three-membered ring, there will be a ring strain. So because of the ring strain, they try to convert into a open chain structure when it is treated with acid, halogen acids. So that is the reason ring opening reactions will occur. And in the case of aziridine, in addition to the ring opening reaction, it also undergo Friedel-Crafts reaction. What it means? It means that aziridine can act as a source of act as a source of electrophile. So that means it can be added to the nucleophile, forming a substituted product. And similarly, aziridines, what I am talking about, I'm talking about yes, this thing. Okay, Friedel-Crafts reaction. Okay. So then nucleophile can attack this carbon, forming a substituted product. And also the NH proton can be replaced with suitable reagent. The reagent may be a alkylating reagent or maybe a acylating reagent. So with respect to the Oxirane, so a oxygen containing three-membered rings are called oxiranes. And similar to aziridine, these also exhibit ring opening reaction. So this can be act as a source of electrophile and symmetrical one and unsymmetrical one. So in the case of unsymmetrical one, it is possible to get one will be the major product, other will be the minor product. Whereas in the symmetrical epoxide, it is possible to get only one product in the case of ring opening reaction. So this is the mechanism. So mechanism means, with respect to mechanism, what you can say that epoxide, when it is treated with acid, forms a protonated one. Protonated one, when it is attacked by a nucleophile, nucleophile attacks the less hindered carbon, forming a major product. That's what you can say. Right. So, okay. So this is phenyl epoxide. It's an symmetrical one, and this will be the only one product is obtained in the case of phenyl epoxide. And then reaction with Grignard reagent. Here also, when epoxide is treated with the Grignard reagent means what we can say that a metal is form a bond with the organic compounds. Okay. And here phenyl magnesium bromide is one Grignard reagent. Methyl lithium is another Grignard reagent. Of course, dimethyl lithium cuprate is also another organometallic compounds. So that means use of organometallic compounds in organic synthesis. Okay. Then here also